Alright, good morning, grade 11s. It's the last day of maths for this week, and we've done the revision, and we've done the period change, and we've done the vertical change, and now we are going to do something new for grade 11, the horizontal shift. So we're not just going to move the graph up and down, we are going to move it left and right. And we can stretch it or we can push it all together. But let's focus on what's going to happen if I do a horizontal shift. So what am I talking about? So the period change yesterday is where I added a value in front of the x. Now you're going to see that x will be placed in brackets, and it will have a plus or a minus a value to it. Now that value is known as my horizontal shift, and it is a p-value, and as you know from your functions experience, what does the p-value do? It moves the graph left or right. Now, as with the other functions, a plus p-value will shift my graph to the left. A minus p-value will shift my graph to the right. So what I want you to do is you're going to pause this video now, because you are first going to take your calculator and work out the values for the table below. I've covered them up. And give them 3 colors while you are busy doing that. Okay, so pause the video, and then once you have filled in the table and you have drawn all 3 graphs, then you can press play again. Great. Right. Okay, so hopefully you did not cheat and you followed the instructions and paused and filled the table out and then drew the graphs. Right, so cos x is my green graph. So as I know, starts at 1 through 90, minimum point at 180, goes through 270, peaks at 360 again. Let's have a look what happened when I added 90 degrees to the x. So I'm looking at the green and the yellow. What did you see? The green moved, because it's plus 90, it moved 90 degrees to the left. So every single point from the green graph was moved 90 degrees to the left. Now if I compare the green graph and the orange graph, orange has got a minus 90. So what does that mean? Each green graph point, the cos graph, was moved 90 degrees to the right. Okay, because plus moves it left, minus moves it right. So please compare your graph, and I hope that you got the same thing. Right, so on the next page, page 13, it's basically what I said. What does the p-value do? If it's greater than 0, it will move the graph to the left. If it is less than 0, it will move the graph to the right. Okay, so now let's have a look at some examples. Let's think about this. Do you think moving the graphs left and right, if I work with tan, it's going to affect my asymptotes? Yes, it is going to affect my asymptotes, but luckily for you, you've got a very clever calculator. Okay, what does minus 45 mean? It means that every single point that I would have had on my original tan graph will move 45 degrees to the right. Okay, So what do I know about my positive or normal tan graph? I know it starts at 0. But I'm not dealing with a normal tan graph. It's going to move 45 to the right. So I'm going to start there. But let's not take chances. I'm going to use my calculator. But for those that want to save time, that's one way to do it. Okay, start at 360, end at 360. There's no period change. I can do every 45 steps because there is no period change. Okay, so at minus 360, I have -1. So minus 360, that's -1. Minus 315, I will have a 0. 270, I will have a 1. And then 225, it gives me an error. What do I do with an error? I put in an asymptote. Okay. Right, so where do we go from there? Minus 180 is -1. Okay, minus 35 is a 0. And minus 90 is a 1. Minus 45 is another error. So it is an asymptote. Okay, now I can see there from my previous knowledge, I know that my asymptotes usually are based at minus 270 and minus 90. Because my graph has moved 45 degrees to the right, look at that. My asymptote has moved 45 degrees to the right as well. So I've got 0 and -1, 45 and 0, 90 and 1. My asymptote used to be at 90, but it has moved 45 degrees to the right, so it makes sense that 135 is now my new asymptote, which means 180 must be -1. It means that 225 will be at 0 and 270 will be at 1, and then 45 degrees later, because 270 is usually my asymptote, but now it's at 315. So at 360, I will have a 1. This is a positive tan graph, so I'm going to start at the middle and I'm going to go up, which means I'm going to go down. Start at the middle and go up, start at the middle and go down. That means I would have had a middle there going up, so that middle will go down that way. Start at the middle, draw up, start at the middle, go down, and then there's my middle. I will go up there and down there. So that is how I will draw tan x minus 45. Okay, the second example there, I've got sine x plus 30. What does that plus 30 mean? It means I'm going to move 30 degrees to the left. So let's test your knowledge. Where does a sine graph start? Usually, a sine graph starts at 0. Now I have to move it 30 degrees to the left. Okay, so to spare your confusion, please number your scale properly, your x-axis. I'm quickly going to do that. Okay, so now instead of starting at 0, I must have a starting point at minus 30. Okay, what did I know about the sine graph at 90 degrees. Usually at 90 degrees, it peaks at 1. That means it's now going to peak at 60 and 1. Normal sine graph will go through 180. Now it's going to go through 150. Okay, so let's check using our calculator whether I've been right. Plus 30. Okay, and I'm going to keep everything as it is. I'm actually, you know what, I'm actually going to do my steps using 30 degrees. And I'm going to start at 0. I'm first going to do the positive side, change it into 30 because that's how my Cartesian plane has been numbered. Okay, so at 0, I will have 0.5. Okay, at 30 degrees, I will have 0.9. 60, I will have 1. Then at 120, I'm going to have 0.5 again. At 150, I have 0. At 180, I have minus a half. At 240, I will have negative 1, which means at 300, I will have a half again, minus a half. 330, I'm going to have at 0. Does it make sense? I usually stop at 360, but my graph has moved 30 degrees to the left. So yes, so at 360, I will have 0.5 again. If I do the same and I start at minus 360, end at 0, step at 30, okay, I'm going to have a half at minus 360. I'm going to have 1 at 300. I'm going to have 2 minus 240. I'm going to have a half again. I'm going to have 210 and 0. I'm going to have 180, minus 180 and minus a half. I'm going to have minus 120 and negative 1. I'm going to have minus 60 and minus 0,5. And there we go, minus 30 and 0. So when I draw this, okay, that is my sine graph, but 30 degrees to the left. Right, you are going to do exercise 3, question 1, 2, 3, and 4 for homework today. We don't have maths on a Friday, and on Monday there will be no video lesson. Please follow the online program where you get the right numbers to do from exercise 3. You leave out question 5. You carry on with question 6, and I have identified the numbers that you need to do. So on Monday, you spend the time that you have allocated for maths to complete the numbers of exercise 3. The memo will be released and during the middle of your lesson roundabout. Have a nice day, grade 11s. Have a good weekend. Stay indoors, stay warm, stay safe. I miss you. All the teachers miss you. And we hope to see you soon.